Have you ever looked at a bunch of numbers and just had a gut feeling that there's a story hiding inside, a secret connection just waiting to be found? Well, today we're going to pull back the curtain on one of the most powerful tools for finding those hidden patterns. We're talking about simple linear regression.
I mean, think about it. You hear this stuff all the time, right? The more you study, the better your grades. The more you advertise, the more you sell. But how do you go from just a hunch to actually proving it? How do you show with cold, hard data that two things are connected? That's the big mystery we're going to solve today.
And our secret weapon is simple linear regression. It really does two incredible things for us. First, it tells us if there's a real statistically significant relationship there. One that's not just some random fluke. And second, once we find that relationship, we can use it to predict the future. It's kind of like being a detective and a fortune teller all at the same time.
Now, that word regression might sound a little intense, but I promise you the core idea behind it is something you've already seen, probably way back in a high school math class.
Yep, at its heart, it's just the good old equation for a straight line. Seriously. Now, in statistics, we like to use these fancy Greek letters, beta naught and beta 1, instead of B and M. But don't let that fool you. The idea is exactly the same. We're just trying to draw the best possible straight line through our data points.
So let's break that down real quick. That first part, the intercept, or beta naught, that's just our starting point. It's where our line crosses the vertical y-axis. But then you've got the slope, beta 1, and this is where the magic happens. The slope tells us how steep that line is.
And trust me, the slope is everything. If the line is flat, it means there's no relationship at all. But if it has a positive slope, it tells us that as one thing goes up, the other thing goes up too. And the steeper that line gets, the stronger that connection is. The slope is literally the number that tells our story.
Okay, so drawing a perfect line sounds simple enough. But here comes the twist. Because, let's be honest, the real world is anything but perfect. And that's actually where this all gets really interesting. Just look at this. In reality, our data points are all over the place, right? They're scattered. They don't just fall into a perfect little row. There's always some noise. So our goal isn't to draw a line that hits every single dot, because that's impossible. Our real job is to find the one single line that best captures the overall trend, the best fit. And what about those gaps? You know, the distance between each of our real-world dots and our perfect line? Well, statisticians have a name for that, the error term. And it's not a mistake. Think of it as all the real-world randomness, all the other little things happening that our simple model can't quite explain. All right, that's enough theory. Let's be real. The best way to get this stuff is to see it in action. So let's take this idea and apply it to a real-world problem.
We're going to tackle a classic question from economics. Is there a real connection between how much a family earns and how much they spend? I mean, it sounds pretty logical, right? But can we actually prove it? And even better, can we measure exactly how strong that connection is?
Okay, first things first, we've got to define our roles. The thing we think is causing the change, in our case income, that's our independent variable. We'll call it X. And the thing we're trying to explain or predict, consumption, that's our dependent variable, or Y. Its value, you see, depends on income.
So we go out and collect the data. For a bunch of families, we get two pieces of information, what they earn and what they spend. It might look like just a simple table of numbers, but the story we're looking for is hiding right in there.
So we plug these numbers into some statistical software, and boom, it spits out a table that looks like this. Now I know, it looks like a whole lot of jargon, but just take a breath. For right now, the whole story is told by just two numbers you can see right there in the coefficient column. Those are the only two that matter.
All right, this is the moment of truth. We've got our numbers. Now it's time to translate them from math speak into a plain English story that actually means something. This, right here, is the real magic.
So when we grab those two key numbers from our output, we can build our final equation. This little formula right here, that's it. That's our story. It's our model for how income and spending are connected.
So let's decode it. The most important number here is 0.85. That's our slope, and it tells us something really powerful. It says that for every additional $1,000 a family earns, our model predicts their spending goes up by about $850. See, we've just put a number on it. We've quantified the relationship.
And the other number, 49.13, that's our intercept, our starting point. It suggests that a family with absolutely zero income would still spend a certain amount. Now, in the real world, you have to be a little careful interpreting the intercept, but for us, you can just think of it as a baseline level of consumption that happens no matter what.
And that really gets to the heart of it all. Yeah, we used some math to find a line that fits our data, but that was just the tool. The real power isn't in finding the line itself, it's in understanding what that line is telling us about how the world actually works. It's about turning those numbers into a real story.
So there you have it, the basic toolkit. Now it's your turn. The next time you come across some data, whether it's in sports or business or science, just stop and ask yourself, could there be a straight line hiding in there? A simple line that tells a powerful story? What connections are hiding in plain sight, just waiting for you to find them? Thanks for joining me.